Welcome to this lecture on robot and effectors. My name is Atchuta Ramacharyulu and I am working as an assistant professor in the Department of Mechanical Engineering. So we are discussing the course Elements of Mechanical Engineering, where we are in the fifth module studying the automation in industry. So today's topic is robot and effectors. So we are going to discuss. In the previous lecture, we have discussed what is a robot and what are the different joints used in robot, what are the different types of configurations in robot. We have seen what is a robot wrist, etc. So today in this class, we are going to see what is a robot end effector. So we'll see end effector. The basic definition of end effector is the device which is attached to the wrist of the robot that enables the general purpose robot to perform a specific task. You can see in this picture, there is a attachment connected to the end point of the robot. So this thing is called end effector. Okay. We can see in the second picture, this is the wrist of the robot. We have seen in the previous lecture what is a wrist of robot. The robotic wrist is a moving mechanism which will have 3 degrees of freedom. This moving mechanism which will make the robotic end effector move in 3 different directions. So the end effector is nothing but the attachment which is kept to the robotic link in order to move. And here we can see there are 2 types of end effectors. First one is gripper and second one is tools. So there are different tools we can attach to any robot, or we can attach different types of grippers which can be used to manipulate the things. Now, in robotics terminology, we use the word manipulation very often because the word manipulation itself indicates the movement of the robotic arm or the movement of the robotic object along with the robotic arm. So, if we want to pick and place an object using a robotic arm, so the robotic arm will move from rest position to the position where the object is there, and from there it will pick the object from point A and it will move from point A to some point B. There it will remove or place the object at point B, and again it returns back to its original rest position. So this entire thing, the movement of the object from one place to another place, this entire thing is called as manipulation. So the robotic arm is also called as a manipulator. So the end effectors are 2 types, grippers and tools. So the tools are, we'll see in detail what is a gripper and what is a tool. So what is a gripper? To grasp and manipulate objects, we will use grippers. You can see in this picture, this is a mechanical gripper. The black color parts are the gripping elements. They can be moved, they can be closed towards. If an object is placed inside, they can be moved towards and they can hold the object very tightly so that it can lift the object from ground. So this is one kind of gripper. There are many other kinds of grippers are there. So they are mostly used for pick and place operations. Like they can pick one object from point A and move that object to point B. So this is one example of a gripper. And then second type is tool. So the tool is used for, mainly the tools are used for different operations like welding, painting, machining, etc. So these are the different operations that can be done by multiple tools. So in the second picture we can see there is a machining element attached to the end effector of the robot. Now this machining element, this is called a drilling machine. This can drill holes in the body parts of any automobiles or mechanical elements. Okay, so we will see in detail what are the different types of grippers being used and what are the different types of magnets what are the different types of tools that are used in robotic industry. I'll go to the next slide. So we'll see what are the different types of grippers. This is a gripper where it is called as mechanical gripper. Mechanical gripper is nothing but it uses some kind of mechanical elements or moving body parts for holding an object. You can see in this picture there are three different types of grippers are there. All these three are mechanical grippers. They will use some kind of servo motor mechanism to open and close the arms of the gripper. Now see in this picture, these are the arms. This is one arm and this is second arm. 1, 2. So all the grippers have like two arms. They can have more than two arms also. In this picture we have two arms. These two arms are mostly manipulated with the help of a servo motor. Servo motors are used and this manipulation is done by closing the two gripper fingers towards the object. The blue color object is the one which we want to move or which we want to hold with the help of a mechanical gripper. Now see, these three are different. First one is designed in such a way that it can hold circular objects. Okay, circular objects can be held. Second one is where we can hold cylindrical objects. Cylindrical objects can be easily handled with the help of this kind of gripper. And third one is, this is an internal gripper where we can insert the gripper into the body. Here we have inserted the gripper inside the body and the gripper fingers will be aligned outwards. When they move outwards, they will hold the object and they can move the object. Okay, so these are the different types of mechanical grippers. So mostly mechanical grippers uses some mechanism which is operated by a servo motor or something. So in order to grasp the object, the mechanical grippers will move in and out. Okay, so the next type of grippers, magnetic grippers. So magnetic grippers are the one which can be used magnetism of a element, and because this magnetic grippers uses magnetism, these grippers can move the objects which are made up of iron or ferrous related elements. So only magnetized elements can be lifted by using this magnetic gripper. We can see in this picture there is a magnet connected to the end effector. There is a magnet connected to the end effector which is in turn connected with the electricity, and to receive some signals it is connected with wires. And all this mechanism will work in such a way that whenever we want to hold an object which is made up of ferrous, so mostly ferrous metals are magnetic, so this is magnetized, the red color part is magnetized. This device is used to hold the object by simply placing the magnetic gripper on the object. So some certain rules are there for using the magnetic gripper. There are some disadvantages and advantages of using this. So this uses magnetic energy for holding the objects, only suitable for ferrous elements which are magnetic in nature. Other than magnetic elements, we cannot use the magnetic gripper. For other elements like plastic, we cannot use this one. We have to replace this with mechanical or some other kind of gripper. So, in order to have a complete grip on the object, the magnetic surface of this gripper should be in contact with the object. So, the entire surface of the gripper should be in contact with the surface of the object. If this is an object, so the object surface should be in contact with the magnetic gripper. Otherwise, it cannot hold the object. So, because of the very low power of magnetism available, the objects which can be gripped by using this magnetic gripper are very limited. Only small size objects can be gripped with this magnetic gripper. Okay. As we are talking about magnetic gripper, there are two kinds of magnetism. One is permanent magnet and another one is electromagnet. Why do we want to discuss permanent magnetism and temporary magnetism, which is also called as electromagnetism? Because there is one disadvantage of using this magnetism or magnetic gripper. That is, when I am using a permanent magnet, then what happens is this magnetic gripper, when it is moved towards the object, it will hold the metal part. After holding the object along with the mechanical gripper, it can be moved from one place to another place. And when it reaches the end point where the object has to be separated from the magnetic gripper, we have to use a separate tool or a separate robot has to be used in order to remove the object which is magnetically attached to the magnetic gripper. So that is why this is one major disadvantage of using permanent magnet in the magnetic gripper. We cannot use magnetic gripper with a permanent magnet because we have to use a separate tool for removing the object from the magnet because it cannot lose magnetism instantly. So that is why we have using electromagnetic plates where we can induce the magnetism when we supply electricity into the magnet, and whenever the electricity is removed from the gripper, the magnetism can be lost. So this kind of magnets are very widely used in the industry where we are working with ferrous elements. Here we can see permanent and electromagnets are there. Permanent magnets are permanently magnet, they cannot be demagnetized easily. So that is why we are using electromagnets at some places where we need to remove the object instantly, and this everything in electromagnetism can be done by electricity. We can simply pass the electricity to get the magnet magnified, and if we want to remove the magnetization, we will simply cut off the power. And then here there are some points which we have to discuss about why we should use magnetic gripper and why we should not use magnetic gripper. The one thing is the gripper gets demagnetized when heated. So this is one important point where magnetic grippers are failing. When we are working in an environment where the temperatures are very high, more than 100 degrees centigrade, then the grippers will lose their magnetism. As we are talking about permanent magnets, if the temperature is above 100 degrees centigrade, they will lose that magnetism. So that is why we have to use the magnets or permanent magnets only when the surrounding environment temperature is below 100 degrees centigrade. If the temperature of the surroundings is above 100 degrees centigrade, we should not prefer using a permanent magnet. And then the second point is the metal object will get magnetized sometimes, which means when we are attaching the magnetic element to the magnetic gripper, like I have a metal iron object, I am holding the iron object with the help of a magnetic gripper which has magnetism. This magnetism is induced into the iron object. So what happens? The iron object will, after removing the object from the gripper, the iron object will still have some amount of magnetization attached to induced in it. So this is one disadvantage of using magnetic grippers. The objects will still be magnetized even after removing from the magnetic gripper. And third point is electromagnets is used in most cases, which will reduce the use of a separate tool for removing the object from the gripper. So we want to use separate tool to remove the objects from magnetic gripper where we are using permanent magnet. So in order to avoid the usage of a separate tool for removing the magnetized part from the gripper, we will use simply electromagnet. So in this picture we can see an electromagnet is there. This electromagnet is induced the magnetism when electricity is passed to it. Then it will hold the object. This is the object which we are holding with the gripper. Now this magnetic gripper, when power supply is cut off to this magnetic gripper, the object will be removed from the magnetic gripper. Okay. Now another disadvantage of using this is whenever there is power outage. Whenever there is a power outage in the industry, maybe for a small fraction of time. So the electromagnets will instantly lose their magnetism when the object is in process. Suppose I am using a robot for doing some operation like pick and place operation. I am using a magnetic gripper which can hold a load of about 50 kilograms. So the magnet is so powerful that it can lift 50 kilograms of a iron billet. Okay. Now, if there is a sudden power outage, what happens? The electromagnetic magnet will instantly loses its magnetism, and the object which is lifted by the uh, robot will be instantly fell down. So this is another disadvantage of using the electromagnetic grippers. Okay, so this is all about the magnetic grippers. Now we'll see vacuum grippers. So here we can simply see that the vacuum grippers uses some kind of compressed air. They will use some compressed air and suction cups, so which are made up of rubber to hold objects. So you can see in this picture the suction cups present here are mostly made, they are imitated in the form of octopus body. We know there is a living organism in oceans called octopus, where the octopus body is completely made up of cups like this, similar to what we made in the vacuum gripper. Okay, so what happens is when these suction cups are placed on a object, now here we can see there is a box which weighs about 16 kilograms. We have placed the robotic arm on the box and we have sucked the air from the suction cups using a air compressor. So then what happens is these suction cups, which are made up of rubber, they will hold the object very tightly so that the object can be easily lifted up. Okay, see here, these suction cups will suck the air when they are pressed against the weight or object which is to be lifted. See in this example, there is a net weight of about 16 kilograms it can lift, which is very large when compared to remaining grippers. Although there are grippers which can carry more load, because we are using suction cups with compressed air. So this is very high value when compared to other grippers. Okay, so this type of grippers will provide good handling if the objects are smooth, flat and clean. What if the objects are very smooth? Like in mechanical engineering, most of the metal parts are made very smooth. They are very surface finishing is very done on the surface so that they will become very smooth and there is no hardness on the surface, so that they cannot be holded with a mechanical gripper or a magnetic gripper. Sometimes I don't want to magnetize the mechanical part, so that is when I will use this vacuum gripper in order to hold the object from one place to another place. So when the surface is flat, we can use this, and if we want to use a clean transfer, that means I want to transfer the mechanical element from one place to another place without making any disturbances to the surface. If I use a magnetic gripper, I will magnetize the body. That is one problem. If I use a mechanical gripper, I may make some marks because of the gripping of the mechanical elements on the object. So that is when we will use the vacuum grippers. Okay. So the vacuum grippers are very widely used nowadays because of their increasing capacity of bearing the loads. So next kind of gripper is, so this is another type of gripper which uses a bladder. So this bladder is made up of rubber. Now expandable bladder type gripper is used for lifting the objects like bottles when they have a narrow opening. So narrow physical sized objects can be lifted using the expandable bladder type grippers. Now we'll see how this expandable bladder gripper will work. So it uses a compressed air and bladder for holding the objects. See here, this black color thing is called a bladder, which is made up of rubber. So this bladder, when compressed air is sent into the bladder, it can expand. Now what happens is, when I push the bladder into the bottle before inflation, inflation means when we pump air into the bladder, then the bladder will expand. This expansion is called as inflation. So before inflation, before the expanding of the bladder, we will send this entire thing into the bottle, and once it entered into the bottle, we will send compressed air into the bladder so that it expands and holds the bottle from inside. Now I can lift along with the bladder, and along with this entire arrangement, I will lift the bottle from one place to another place. And after it reaches the end point, the bottle will be removed by simply removing the compressed air from the bladder. Okay, so this operates very slowly when compared to other kinds of grippers, because we have to carefully insert the bladder into the bottle and then carefully inflate it. We have to send compressed air slowly without disturbing or without causing any damage to the bottle. Then we have to send a little amount of air. We cannot send large amount of air into the bladder because it may cause damage to the bottle. So after that, we can, because of this entire thing, this operation is very slow. They do not operate fast. Their operation is very slow, and this kind of bladder arrangement, the expandable bladder gripper, is mostly used for glass items, where we have to hold the glass items very carefully. When I use a mechanical gripper for holding a glass item, it will simply break because of the force exerted by the gripper on the object. See, mechanical gripper is very normal, which contains levers made up of metal. When I use this metal gripper for holding a glass body, it will simply break the glass body. That is when we have to go for expandable bladder type grippers. So these are also useful for objects with a narrow range of physical sizes. So the expandable bladder type grippers cannot be used for all kinds of items. They can be used for a very narrow range of elements will be there, like bottles, glass bottles, small jars, etc. So for those elements only we can use the expandable bladder type grippers. Now we'll see what are the tools, different tools attached to the robots. So different types of tools can be attached to robots. One tool is, so the first kind of tool is welding, painting, machining. So you can see in the pictures below, different types of tools can be connected to the end effector. So the end effector will move in such a direction. The tools will work on the end product or the object on which we have to work. So far we have seen the grippers. What is the main function of a gripper? Gripper will hold the object for some time. It may be moved from one place to another place, or it may be machined by another robot or something else. So gripper's function is to hold the object for a certain time. Now what happens is, when we attach a tool to the robotic end, so the end effector is now replaced with tool, we can do different operations. Okay, different operations like welding, like we can weld the parts. See here, the robot is welding a metallic plate. The robot itself is doing the and it is holding the welding torch, and it is doing the operation or welding operation on the metal plate. So there is no need for human. And again, in the third picture, we can see the robot is painting the car body. Okay, because nowadays the car bodies are more complicated. They contain lot of inside interior parts where human beings cannot reach and paint the body. So that is why, uh, in fact, this painting environment is very hazardous to human beings, because the very fine jet of spray will be fine jet of paint will be sprayed on the body. So if a human being inhales this paint, it causes very hard medical damage to the human body. That is why nowadays human beings are replaced with robots for painting the car bodies. Now see here, the car body is painted with the help of a robot. The robot is painting the car body, and this car body inside also, inside the car body also can be painted with the help of a robot. So what happens is, when we use robot for painting, it not only work with accuracy, it will take less time when compared to human being. Suppose a human being or a skilled person takes about 1 hour to paint this entire car. This robot can paint the entire thing in less than 15 minutes. So that is why robots are being replaced, even though robots are very expensive when compared to humans. Okay. Nowadays, artificial intelligence is very rampant, and artificial intelligence is taking over the human race. Whenever we talk about robots, the robots have the ability to think on their own. How does this thinking capacity came to the robots? Because robots have artificial intelligence. When they have artificial intelligence, they can think on their own. They can change their path according to the situations. They can change their learning, or they can change their behavior according to the surroundings. Okay. Now, whenever a robot is painting the car, whenever some obstacles come into picture, suppose I kept a hand while painting the car, what happens is, it will stop painting and it will check for errors. What are the errors? Why, other than the car body, why a human being or some other object is appeared in the between? And the robot will try to understand the situation, and it will modify the code accordingly, and it will stop painting for a while, and it will check the surroundings, and it will start painting again. Now, this is how advanced the robots are. Mostly the humanoid robots now being developed are very advanced when compared to all these things. See, these are industrial robots which works automatically. They will use some kind of robotic program where we will give the code to move from one place to another place. So the robotic program will follow the set of instructions given to the given in the form of a code, and this code will be run by the computer. So computers are connected to the robots. Now see, in the first picture we can see the robot end effector is connected with a drilling machine. Okay, so this can be used to make particular drill holes on the metal bodies. So when we are making holes on the body, there are two things. First thing is, we have to locate the position. And second one is to drill a hole. So these two things should be done one after the other, and they should be done perfectly. The calibration of the robotic arm should be done in such a way that movement of the robot should be accurately done. Even the artificial intelligence which is attached to the robot will make it think whether the object is placed at the correct position or not. If I have an object on which I have to make a hole, suppose I given the command to the robot that make a hole at the center of the plate. First of all, the robot has to identify the center. For that, it has to identify the plate first. So the robot is fixed with some kind of sensors, where this sensor will sense the object position. Like they will use different kinds of sensors like position sensor, vision sensor, color sensors. So these are the different types of sensors used by robots for sensing the object. Now this robot will sense the object, and it will also sense the dimensions. Then It will go to the center of the plate by carefully observing and studying the body of the object by using different types of sensors. So there are two things. First of all, it has to locate the plate, and then it has to drill a hole. So depending on the drill bit size, the hole size will depend. So third thing is how deep it has to drill. Depending on the plate thickness also plays a very important role. So if the plate is very thick, the robot will automatically scans the thickness of the plate by using a position sensor, and it will cut as deep enough as required. If we want to make a hole which is halfway into the thickness, that also can be done with the help of the robot. If I want to make a through hole to the plate, that is also possible if we are using a robot. Okay. So these are the different tools that can be connected to robots as end effectors, and they can be used for doing different operations. These are some of the examples. Still, there are many other tools that can be attached. Okay. So in the coming session or the coming class, we will discuss about sensors. What are the different sensors used in robots and how do they work? There are different sensors like potentiometer, and vision sensors, pressure sensors, and there is a sensor called optical encoder. So we will see what are these sensors and how do they sense the information, and how do they work. We'll see in the next lecture. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.